Sorry, guys. All right, I know you guys are super pumped up to learn about more segment and angle properties, and this one in particular, we'll be focusing on some segment addition postulate and angle addition postulate properties, and also some other angle and segment properties that are usually incorporated with these concepts. So get pumped up. All right, so first of all, we need to talk about something called a segment bisector. So a bisector, it's this mean little object. It could be a segment, ray, or line that slices something in half. So it cuts something in half and hits it in the middle. So a segment bisector will slice a segment in half and hit it at the middle point, which is the midpoint. So again, a segment bisector is a line, segment, or ray that intersects a segment at its midpoint. Okay, so we start with this segment, and then, oh no, the segment bisector comes in and slices it in the middle and hits it at the midpoint, which in this case is point O, which makes it split into two congruent pieces, okay, because midpoints lie in the middle and create two congruent segments. So if line IO bisects AB, then O is the midpoint of AB, which means it splits it into two congruent segments, segment AO and OB. Okay, so be on the lookout. Segment bisectors are kind of mean. They slice things in the middle, cut things in half. All right, so what do you think an angle bisector is then? Oh no, it's going to be slicing an angle in half. So it's some line, ray, or segment that will divide an angle in half. So again, a segment or ray, that should say or ray, sorry guys. It could also be a line, but anyways, it's some sort of object that divides an angle into two congruent angles because it hits it in the middle. So like if you look here, if ray AB, so A to the B, if it's a bisector for CAD, which is the big angle, it will slice it in half, and if you see, it created two congruent angles. Angle CAB, this upper one, and angle BAD. So again, bisectors slice things in half, cut it in the middle. Now, the angle bisector theorem states that if AB is an angle bisector, then there are some properties that arise with this angle. So one way, to get from the little angles to the big angle, if you double the little angles, since this is the halfway point at your bisector, you will get the larger angle. So if you double angle CAB, you will end up getting CAD. Alright, and if you double BAD, angle bad, watch out. If you double that one, you get angle CAD. So that's one of the ways. Or if you reverse the way that we get from the large angle to the little angles is by halving the measure of the big angle. So if we halve the measure of CAD, we will end up getting CAB or BAD. So that's why CAB equals 1/2 CAD, or angle bad is half of angle CAD. So those are some angle bisector theorems for you to recognize. Alrighty, the next type of angle and line kind of property we're going to talk about are perpendicular lines. So what are perpendicular lines? Well, they are two lines that intersect, and when they intersect and slice each other, it doesn't have to be in half, but when they slice each other, they will form right angles. So they will intersect each other at a 90-degree angle. Okay, and the symbol we use for perpendicular is this upside down T. So if you see that, remember mathematicians are lazy and we don't like to write things out if we don't have to. So if you see this perpendicular symbol, it means perpendicular. We don't have to write out the word perpendicular, which is kind of cool. So in perpendicular, when two lines intersect, bam, will form 90-degree angles. And if one angle is 90 degrees, it will also mean that all four of them are 90 degrees technically, which is cool. Sorry, guys. Oh, the demon cat got me right there. Sorry, guys. Did not mean to have a coughing fit in the middle of this PowerPoint. That's embarrassing. But anyways, if CD, so if line CD is perpendicular, that means perpendicular to AB, then angle CDA is a right angle. And also, like I told you, all the angles are actually going to be right, which is cool. All right, so we've talked about the word perpendicular and we talked about the word bisector. So what is a perpendicular bisector? Well, perpendicular means two lines that intersect and form 90-degree angles, and bisector means when something intersects something and slices it in the middle. So maybe, just maybe, a perpendicular bisector are two intersecting lines that make 90-degree angles and hit at a midpoint. Okay, so the formal definition is a line, segment, or ray, that should have a comma, sorry guys, line, segment, or ray that is perpendicular to a segment at its midpoint. So it will form 90-degree angles when it slices through the midpoint. So this one's kind of cool because it combines more than one of the properties that we talked about, which is cool. Okay, so if you see here, CD is a perpendicular bisector because when it slices through segment AB, it forms a 90-degree angle and it hits the midpoint, and I know that because there are two congruent segments right there. All right, so line CB is perpendicular to segment AB. All right, and since it is, that means that CDB is a right angle, and also that D is the midpoint, so yay. All right, so example 1 and 2 are going to be combining all these properties of segments and angles that we talked about, in particular bisectors. So be on the lookout, you guys. We're going to be slicing a lot of things in the middle on these examples. So go ahead and pause the video and watch example 1 and 2. All right, you guys, the segment addition postulate is the next thing we will be discussing. And basically what the segment addition postulate states, okay, if we start with a segment, okay, a segment that contains more than one segment within it, basically if we add up the smaller pieces of the segment, we will get the entire segment. So, if I start with segment AB, and I add it to its other piece, segment BC, guess what, you guys? It equals the length of the entire segment, which is AC. So basically, we're breaking a segment down into its two pieces, which when you add its pieces together, bam, you'll get the length of the entire segment, which is pretty nifty. All right, well, example 3 and 4 are going to incorporate these properties of the segment addition postulate. So we'll be breaking down a segment into its pieces, and when we add those bad boys together, we get the length of the entire segment. All right, so go ahead and pause the video and watch example 3 and 4. And that's the funsy. You'll have to wait on that, though. All right, guys, so we talked about the segment addition postulate. Guess what, you guys? The angle addition postulate is pretty much the same thing. We just have angles this time. So we can break a larger angle down into its smaller angles, and when we add the smaller angles together, we will get the larger angle. So basically this is going to say angle AOB, so the measure of this angle plus the measure of angle BOC. When we combine these two angles, we get the larger angle, which is angle AOC. So that's kind of what the angle addition postulate states. All right, and guess what? We have two nifty examples to work out on the angle addition postulate. So go ahead and pause the video and watch example 5 and 6. And that's it. Oh no, I'm sad it's over, you guys.